When it comes to terminology, we try to always make sure everybody understands where they're starting with and where they want to go to. My name is Zaya. I'm a product specialist here at Big DAISHOWA. CNC machining is a fairly broad term, but basically it stands for computer numerically controlled machining. Machining Center allows you to take a raw workpiece, casting, whatever you might need, put it in the machine and use a computer to control the movement of that machine to take a tool in a tool holder, cutting tool in a tool holder, and drill your workpiece, mill your workpiece. Whatever you need to do to it, the controller of the machine allows you to do that without having to manually input all that information or control the machine. On the machine, we generally will have a table, and on the table we'll put our work holding and our part. On the spindle side of the machine, that's where our tool holder and our cutting tool go. The table is where your work holding is going to go, and then your workpiece is going to go on top of the work holding. The table can either move or be stationary, and then everything moves around it. Machine spindle is the portion of the CNC machine where the tool holder is held by the machine. Generally, you have a taper and a V-flange. The V-flange is there so that the machine can grab the tool, take it in and out of the machine spindle, and the taper is there to locate the tool in and out of the spindle. The tool holder is the bridge between the machine and the cutting tool. This is a tool holder, and basically when we're looking at a tool holder, we have a couple of key components or features of the tool holder. Starting from the back, we have a pull stud. The machine will generally use this to pull the tool into the spindle. Then we have a taper, and the machine uses this to locate into the taper of the machine spindle. We have a flange. The flange is used by the machine to grab the tool and move it inside of the machine. Then we have the tool holding end. In this case, this is a collet chuck. And then we have our cutting implement. In this case, this is a drill. These can change based off the requirements of the workpiece or the cutting implement that you're using, whereas these will generally remain the same for every single machine that you have. When we're looking at a machine tool, a milling machine or a lathe, they have vastly different types of tool holding requirements. A milling machine will generally have a tool that rotates about its own axis, so that tool has to be very capable of having a very low runout and very good balance characteristics. On a lathe, the workpiece is rotating about its center line, so the tool holding doesn't necessarily have to be high performance in terms of requiring a high rotation capability. Runout is defined by the difference of the center line of the cutting tool relative to the center line of our taper. So if this taper is theoretically rotating at 0, any amount of deviation from that center line is called runout. The workpiece complexity drives how you have to hold on to the cutting tool. So if you have a very simple workpiece, the tool holder, the machine, they can do very simple, straightforward movements. But as the part becomes more and more complex, the ability for the cutting tool to withstand the geometry that it needs to cut becomes very important. So what will end up happening is the machine complexity becomes higher. So you get machines with higher RPM, higher torque, more powerful spindles. But then you'll also get machines that have more axes to their movements. So a 3-axis machine only moves in X, Y, and Z. But as you get more complex, you have to add additional axes. So one more axis generally will get you into what's called a horizontal machine, which adds a rotational axis. Once you get more than that, now you're into 5-axis workpieces where the machine has 2 rotational axes as well. So that gives you a lot of complexity and a lot of movement capability that your part can have, because now the machine can accommodate that movement requirement. Big Plus is a dual contact system from a variety of different tool holder manufacturers. What will happen is, in a standard tool, you have only the taper contacting the spindle of the machine. But with a Big Plus tool, you'll notice that this face is also ground surface. And what will happen is this surface will also contact the face of the spindle. This allows for a more rigid interface between the tool holder and the machine spindle. Generally, any excessive wear on a tool means money out the door that is not being used correctly. That means the workpiece could be out of spec. It means your tool is not working correctly, and so you have to replace your tools more often. So all of that can translate to basically not making good parts and wasting time and money. Another topic of discussion that I often find myself having to explain to people is industrial standards, especially with newer people that are coming into the industry. A machine has a standardized spindle based off of a national standard. So here in the States, we have an ASME standard that we follow so that every tool holder is designed around that standard. There are international standards, and then even separate countries have their own various standards. So when you're looking at a machine, understand that there is a standard interface for that tool, and when you're looking at purchasing tools later, the more common the standard, the more common the tool holders. A premium tool holder manufacturer, yes, they will follow the standard, but they will usually go above and beyond that standard to make sure that it's at the absolute highest quality that they're able to provide. Big Daishowa follows multiple standards. So we offer, here in the States, the ASME standard CAT tooling. We also use the Japanese standard for BT tooling. Out of Germany and Europe, we also have the HSK standard tooling that is offered quite a bit in Europe. There are other standards for Capto tooling that we also follow as well. There are variations of many of these standards where a certain feature might be slightly tweaked, but for the most part, it will follow a lot of the same individual features.